Hello everyone, so today we will look at another problem, sliding window problem. So I will be discussing what a sliding window problem looks like and how can we approach to a sliding window problem. So whenever we have a question like find the sum in a contiguous block. So like we need to find the maximum sum in a contiguous block of range 4. Yeah. So what we do is in a naive approach, we'll be finding all the blocks of length 4. We'll be doing the sum. And then storing it in our some maximum sum variable. And whatever is the maximum, we'll be displaying it. That would be the answer. So this would be the naive approach, and this would take nk time, the go of nk time, and k is the size of the continuous block. So in this problem, what we can do is we can use sliding window. So we have already, suppose this was our sum, this is 10. What we can do is, instead of calculating this sum again, we'll just slide our window here and subtract this and add this. So we don't need to compute this sum again. Then further, if we go, we add this and subtract this, and we don't need to compute this sum. So what we are basically doing is traversing the array just once and just subtracting and adding things. So that would be the go of n. So this was a simple example of sliding window problem. And to see what a sliding problem looks like is we have to find the min, max, longest, shortest in contiguous groups. And we do not want to compute the things again. We can use a pre-calculated stuff in this kind of problems. So let's move to a more complex problem. So you can try solving this in LeetCode if you've got the concepts right, or you can see. So we need to find the longest substring without repeating characters. So we have this string ABC, ABC, BB. Now we need to find the longest substring without repeating characters. So what would be the longest substring? This is of length 4, and then we reach for P again. So we reach A again, so this is of length 3, then CV, this is also 3, so here maximum is 3. So what can we do here? So the naive approach would be, we'll be just computing all the substrings, we'll be calculating all the substrings and then finding out if that substring contains the maximum characters or not, repeated characters or not, and whichever substring has no repetitive characters, we can just print that output, whichever has the maximum sum. So by using the sliding window, what we can do is, we have calculated this thing. Now we reach a point here, A. So we can use the fact that A is already there. We will store it in hash map. And once we get to a stage where we already have an element, we'll start our low pointer from here. This is our left side of sliding window, and remove things till here. So suppose the string was this and A, and then we come here, and this was also some characters, and all unique. These are all unique characters. Okay. So once we reach again a repetitive character, we've already this sum. We have already calculated this by using a sliding window. Now we reach a repetitive character here. So what we can do is we can just go to this position and remove all the elements from the hash map till here, and then our sliding window would be from here to here. And if again we find some A, we'll remove things from here and our sliding window would look like this. So what we are doing is we are traversing once, and this you can say twice, so big O of 2n would be big O of n. So instead of computing all the substrings, uh, we can solve this problem in big O of n time. So you can see this problem and try it. So here is what I'm doing. I've created a hash map of character and integer. I'm computing traversing through the array, and if the hash map already contains that element, I'm removing all the previous elements. Like if it was here, then I'm removing all of these, and then making our low pointer this, and storing the maximum. If it is greater than the max, then we are storing that maximum and returning the max. So this was the sliding window problem.